Alright, welcome back everybody. In this video we're going to look at some more examples from the slope of polar curves lesson. We'll start here with example 2. We're supposed to find the lines tangent to the curve r equals 2 sine of the quantity 3 theta at the pole. And the first thing that we need to do is we need to figure out when this curve is at the pole. And the pole is the origin, the point 0, 0. So in order to find all the times in the interval from 0 to pi where we're at the pole, we're looking for all the times where the radius is equal to 0, because that's when we're going to be at the pole. So let's see what r value, or what theta values that happens for. It happens at theta equals 0. Let's see, when else is sine equal to 0? The sine of pi, so that's going to be at pi over 3. The sine at 2 pi, it's going to be 2 pi over 3, and at 3 pi, that other endpoint. So those are all the times where we're at the pole. So in order to find the lines tangent to the curve at the pole, they all go through the point 0, 0. All we need to do is find out their slopes. So in order to find out their slopes, x is equal to r cosine of theta, and y is equal to r sine of theta. And so I'm going to find dy dx. Dx d theta is going to be 2 times sine of 3 theta times the derivative of cosine, which is negative sine, plus cosine times the derivative of sine of 3 theta, which is 3 cosine of 3 theta, and dy d theta is going to be 2 times the quantity sine of 3 theta cosine of theta plus sine of theta times 3 cosine of 3 theta. Alright, so dy dx is going to be equal to, and I can cancel those 2's out from the numerator and denominator, so I end up with negative sine of 3 theta sine of theta plus 3 cosine of theta cosine of 3 theta. Oh crap. Backwards. That's my denominator. Boop. Sine of 3 theta, negative sine of 3 theta sine of theta, plus 3 cosine of theta cosine of 3 theta, all over sine of 3 theta cosine of theta plus 3 sine of theta cosine of 3 theta. And now I need to find the values for this slope at 0, pi over 3, 2 pi over 3, and pi. So dy dx at theta equals 0 is going to be, let's see, the sine of 0 is 0 times 1 plus 3 times 0. So that's just going to be 0 over 0 plus 3. 0 over 3. So the slope there is 0. Dy dx evaluated at theta equals pi over 3 is going to be more complicated for us. Let's see, that's the sine of pi, which is 0. And the cosine of pi is negative 1. So negative 3 times the sine of pi over 3. Sine of pi over 3 is root 3 over 2. So this is negative 3 root 3 over 2 over, let's see, the sine of pi, that's going to be 0. The cosine, that's 1/2 times negative 1, so that's negative 3/2. So simplifying that, that ends up just being the square root of 3. Dy dx at theta equals 2 pi over 3 is going to be equal to, let's see, the sine of 2 pi, that's going to be 0. The sine of 2 pi over 3 is root 3 over 2. The cosine of 2 pi is 1, so that's going to be positive 3 root 3 over 2 over, let's see, that first term is 0. Cosine of 2 pi over 3 is negative 1/2. So that's just going to end up being negative 3/2. So that ends up being negative square root of 3. And then for theta equals pi, that's going to be the same as for theta equals 0. So we have three tangent lines to the curve. We have the line y equals 0. We have the line y equals square root of 3 times x. And we have the line y equals negative square root of 3 times x. And so those are all the lines that are tangent to the curve at the pole. Alright. Example 3. Determine the equation of the tangent line to r equals 3 plus 8 sine of theta at theta equals pi over 6. So to write an equation of a tangent line, I need two things. I need the point and the slope. I can get the point by just substituting pi into the expressions that I have for x and y. X is equal to r cosine of theta and y is equal to r sine of theta. And so substituting pi over 6 into both of those, the sine of pi over 6 is 1/2, and the cosine of pi over 6 is square root of 3 over 2. So x is equal to 7 times the square root of 3 over 2, because this right here is 7, and this is the square root of 3 over 2. We know that this is 7, and the sine of pi over 6 is 1/2, so that's going to be 7/2. So there's my point of tangency, and now all I need to write the equation of the tangent line is I need the slope of the curve dy dx. So first I'm going to find dx d theta. That's going to be 3 plus 8 sine of theta times the derivative of cosine plus cosine times the derivative of 3 plus 8 sine of theta, which is just 8 cosine of theta. And dy d theta is going to be 3 plus 8 sine of theta times the derivative of sine plus sine times the derivative of that, which is going to be 8 cosine of theta. And so dy dx is equal to dy d theta over dx d theta and then I just need the value of that at theta equals pi over 6. And let's see, that's going to be 7 root 3 over 2 plus sine of theta is 1/2, and 8 cosine of theta is 4 root 3. So that's going to be 2 root 3 all over, let's see, that's going to be negative 7/2 plus cosine of pi over 6 is root 3 over 2. So 4 root 3 times root 3 over 2, that's 12 over 2, or 6. Hopefully all of my calculations were correct there. And so we end up with, oh gosh, if I multiply all that by 2, no, let's not do that. We've got 7 root 3 over 2 plus 2 root 3. Yeah. Let's combine those. It's going to be 11 root 3 over 2. And in the denominator, I've got 5 over 2. So this is going to be 11 root 3 over 5 for our slope. And now our tangent line is going to be y minus 7/2 is equal to 11 root 3 over 5 times the quantity x minus 7 root 3 over 2. And assuming that I didn't make any calculation errors along the way, that's going to be our tangent line. So alright, that's the end of this video and the end of this lesson. We'll see you guys next time. Have a great rest of your day.